right, so as you guys are writing this down, I am going to go ahead and talk through some of this a little bit, and I'll give you a warning before you definitely need to get a picture. Y-axis symmetry. To test for y-axis symmetry, we're going to replace x in our equation with negative x. We are going to simplify it as much as possible. And if what we end up with after we simplify is exactly what we started with, then we say it has y-axis symmetry. From a graphical perspective, what would it mean for something to have y-axis symmetry? What would I see on a graph? Yes, sir?
It would look the same on both left and right y-axis.
That's absolutely correct. It's going to be identical on the left and the right side of the y-axis. So if I took tracing paper and I copied it and I folded it on the y-axis, it would match up with itself. This is also called, and we will study this more later, but I'm kind of previewing some additional terms here. If it has y-axis symmetry, then we say that it is even.
Odd, not negative.
All right. So y-axis symmetry is even. To test for x-axis symmetry, I'm going to run it almost exactly the same as a y-axis test, except instead of replacing x with negative x, I'm going to replace y with negative y. I'm going to simplify it as much as I possibly can, and if I end up with the same thing that I started off with, then we say it has x-axis symmetry, and I have no special name for this one. It's just x-axis symmetry. And then we have origin symmetry. Origin symmetry is a special type of point symmetry. Even symmetry is or y-axis symmetry, even symmetry is a special type of line symmetry where I would fold it on a line. Origin symmetry is a special type of point symmetry. Point symmetry is where on a graph, if I put a point down, and that is the point of symmetry, and I give it a half a turn, 180-degree spin, it would match up with itself. So this is a rotational form of symmetry. To test for origin symmetry, we're going to replace x with negative x. We're going to replace y with negative y. We're going to simplify it. If we end up with exactly what we started with, then it has origin symmetry. If it has origin symmetry, we can also say that it is odd.
So x-axis is neither even or odd?
That is correct. X-axis is neither even nor odd. Is it possible for a graph to have more than one type of symmetry? Yes. Is it possible for a graph to have none of these types of symmetry?
Yes.
Yes. So it can be even, it can be odd, it can have x-axis symmetry, it can have all of the above, it can have two of the three, it can have none of the three. So when we're testing for symmetry, we have to run all three tests. Snap a picture if you need to. We're going to put up some examples where we are testing for symmetry. You guys good if I go ahead and put our examples up? All right. So we are going to determine the type of symmetry for each, and we are justifying it using our tests. To test for y-axis symmetry, what do I do again?
Replace with negative x.
Yes. Replace x with negative x. All right, so let's go ahead and run that test. So I have negative x equals negative 2y squared. We can divide out a negative 1. I love that you said that. That would be what I need to do to fully simplify this. So I would have x equals 2y squared. Is that exactly what we started with? No. So it does not have y-axis symmetry. Let's come in here and test for x-axis symmetry now. How do I test for x-axis symmetry? Yes, replace y with negative y. So So I'm going to have x equals -2 and then negative y squared. Now be careful when you make this substitution. I'm putting negative y inside parentheses because I got to watch out for order of operations here. I replace it and then I simplify using order of operations. If I take a negative number and I square it, what happens? It becomes a positive. So as I begin simplifying this, this is x equals -2 and then y squared. Is that the same thing that I started off with?
Yes.
Yes. So this has x-axis symmetry. How do I test for origin symmetry? Yes, we will replace both. So I'm going to replace x with -x. I'm going to replace y with -y. As I begin simplifying this, what's the first thing I need to do to simplify it? Not divide by -1 yet. Exponents. -y squared would simplify to give me what? Yes, I would have -2, and then this would be y squared. Now I can divide everybody through by -1 to finish simplifying, which would give me what as a final result? X equals 2y squared. Is that exactly the same thing that I started with? No. So this graph, or this equation, sorry, has x-axis symmetry. All right, let's come over to our middle one here. Let's do our y-axis test first. So I'm going to replace x with -x. I have y equals 1/4 and then -x to the third power. You told me if I take a negative number and I square it, it becomes positive. What happens if I take a negative number and I cube it? It stays negative. So this is y equals 1/4 times -x cubed. How will that simplify? -1/4 x cubed. Is that exactly what I started with? No. Does not have y-axis symmetry. Let's check it out. For my x-axis symmetry, we're going to replace y with -y. So I've got -y equals 1/4 x cubed. Can I simplify that at all? Divide everybody by -1, so I have y equals -1/4 x cubed. Exactly what I started with. No. And then last but not least, we're going to replace both of them to check for origin symmetry. So y gets replaced with -y. X gets replaced with -x. First thing I need to do as I am simplifying this. Yep, exponent first. So I have -y equals 1/4 times -x cubed. Where do we go from there?
Divide by -1.
I can divide everybody by -1. I think I'm going to multiply the -1/4 and -x cubed together first. Oh, yeah, I was going to say, if you already wrote it down like that on your page, absolutely. When I divide everybody by -1 here, I get y equals 1/4 x cubed. Is that exactly what I started with?
Yes.
Yes. This is the same. So we have origin symmetry.
The next one is Y.
Possibly. Remember, it is possible to have more than one type of symmetry.
Oh yeah, it is Y.
All right, so let's check this one. I'm going to replace x with negative x. So I have y equals negative 3, and then I have negative x squared plus 4. Negative x squared is x squared. So y equals negative 3x squared plus 4. Is that the same as what I started with?
Yes.
Yes. So we have y-axis symmetry. I cannot be done, though, because I have to know whether or not it has these other types of symmetry also. So we're going to go through and run our x-axis test. I'm going to replace y with negative y. So I have negative y equals negative 3x squared plus 4. To simplify this, what do? Divide everybody by negative 1. So y equals 3x squared minus 4. Is that what we started with? Nope. So we do not have x-axis symmetry. Let's find out. I'm going to replace y with negative y. I'm going to replace x with negative x. Plus 4. So I have negative y equals negative 3x squared plus 4 when I do my exponent. I divide everybody by negative 1. I get y equals 3x squared minus 4. Do we have origin symmetry? No. So on this one, we only have y-axis symmetry. I'm going to put up 3 more examples and give you guys about 5 minutes to run the 3 tests on all 3 of these. You guys are going to do these on your own, and then we're going to go through and compare answers. I'm going to ask you what kind of symmetry they have. If we need to see the justifications for any of them at that point, we will stop and do it then, in case you didn't get the same thing I did. All right. Take about 5 minutes to find the symmetry on these 3. It's what?
Their camp.
Oh, thank you.
I said they were camp. That's better.
Your cute jeans.
Does part D have y-axis symmetry? No. Does it have x-axis symmetry? No. Does it have origin symmetry?
Yes.
Yes. Does anybody need to see the verification for that? For part E, do we have y-axis symmetry?
Yes.
Yes.
All the symmetry.
We have all the symmetries here. X-axis symmetry. Not an appropriate way to take out frustration. All types of symmetry. This one has all types of symmetry. Absolutely. Before we go through F, though, I'm just curious whether or not anybody recognized the equation for part E. Does anybody know what type of a shape this would make if we were to graph it? So
It would make the one thingy. No.
circle.
Oh, it would?
This would make a circle centered at the origin. It's not a function, but it does have y-axis symmetry. If it is centered at the origin and I fold it on the y-axis, it would match up with itself. If I fold it on the x-axis, it would match up with itself. If I put a push pin down on the origin and I give it a 180-degree spin, it would match up with itself. That's why we have all three types of symmetry here.
All three types of circle.
Not necessarily, but circles have all three types. It is not necessarily bidirectional there. All right, last one, part F. Do we have y-axis symmetry? Nope. X-axis symmetry? Nope. Origin symmetry? Yes, let's go through that one. Are you guys okay if I just do the origin symmetry test? Okay. Origin symmetry, we're going to replace y with negative y. We're going to replace x with negative x. I'm taking that to the 5th power, and it's over 2.
When you're done, can we go over E, please?
Absolutely. When I take a negative number to an odd power, what happens? It's going to stay the same. It's going to stay negative. So I'm going to have negative y equals negative x to the 5th over 2. If I divide everybody by a negative 1, I get y equals x to the 5th over 2, which is exactly the same as what we started with. All right. For part E, let's run our origin test, and then we'll go backwards and do any of the others that you guys still want to see from there. Okay, so on our origin test, I would have 2 and then negative x squared plus 2 times negative y squared equals 4. When I take a negative number and I square it, it becomes a positive. So I would have 2x squared plus 2y squared equals 4. And that is exactly the same. If I replace just one of them with a negative, say I just do my y-axis symmetry test, so I only replace x with negative x, but I leave y unchanged, I would just need to simplify this piece right here. When I take a negative number and I square it, it becomes positive. And so I have y-axis symmetry. My x-axis symmetry would work the exact same way. I would just replace the y and I wouldn't change x at all. But then when I square it, it becomes a positive. So my whole equation overall remains unchanged. Do you guys have any other questions for me as far as y-axis symmetry, x-axis symmetry, origin symmetry? Yes, ma'am.
For F, can you go over the x-axis?
Absolutely. X-axis symmetry, I would replace y with negative y. x remains unchanged. If I divide everybody by a -1, I would have y equals negative x to the 5th over 2. Because x to the 5th over 2 would be the same thing as 1/2 x to the 5th.
So it wouldn't be like, never mind,
Yeah, it's not going to be negative top and bottom. It would just be negative on that entire term. Great question. Yes, sir.
On a test, would you need to see like all the work put out, or if I just literally wrote down the equation and immediately recognized that it would have all three?
So on a test, if you're trying to show me, or a quiz for that matter, if I ask about symmetry, I need to see where you've substituted it in, and I need to see where it's been fully simplified. I don't necessarily need to see all your steps to get it fully simplified if that's something that you do in your head, but I need to see the initial substitution, and then I need to see how it simplifies.
Okay.
So you can shorten it down to just those two pieces. Last thing I want to cover for today is intercepts. What does it mean from a graphing perspective for something to be an x-intercept? What would I look for on a graph and it'd be like, I know where my x-intercepts are?
It would be a number and then 0.
Yes, I got two wonderful answers. It's going to be some number and then 0 when I think about the ordered pair. This is, I'm going to not say there, where the graph touches or crosses the x-axis. So to find this algebraically, if all I have is an equation, I don't have a graph to look at. The way I'm going to find this algebraically, tell me about that ordered pair. Which number never changes in my ordered pair? The y, 0 in the y spot. So let y equal 0, and then we're going to solve for x. Is it possible that a graph has more than one x-intercept? Yes. From a graphical perspective, what is a y-intercept?
Where the graph touches or crosses the
Where the graph touches or crosses the y-axis,
x-axis.
yes. What do ordered pairs for y-intercepts look like?
0.
Yep, 0 and then whatever the y value is. So how could I find a y-intercept algebraically?
That x equals 0.
Yes, let x equal 0 and then solve for y. Be careful before you answer this question. Is it possible for a graph to have more than one y-intercept?
No. I'm guessing no, because you said you can't.
Yes. It is not possible for a function to have more than one y-intercept, but it is possible for a graph to have more than one y-intercept.
Well,
I could graph something that is not a function, but that looks like this. That is crossing the y-axis many, 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 many times.
you could have a step function.
We could have a step function as well.
That could go over the one y-axis.
It could go over the y-axis in more than one location, but in that case it would not be a function. We could have a step expression in that case. Specifically to be a function, and we're going to talk about this more next week, for every input, for every x value, you can have at most one output. If one input results in more than one output, which graphically means that I could find more than one spot that has that same y value, or sorry, has that same x value but different y values, then it would not be a function. All right. I want you guys to get these written down. I only want to do the first part of A right now because I know we're running short on time. Let's just find our y-intercepts on this one? How do I find a y-intercept again?
You're at,
It's 0, yes, but 0 where?
let x equals
Let x equal
0.
0. All right, so I'm going to leave the y alone. I'm going to replace x with 0. So I have 0 squared plus 8 times 0 plus 7. How does this simplify?
Just 7.
Yep, y equals 7. So my y-intercept would be what?
Well, 0, 7.
0, 7. We will find our x-intercepts for this one tomorrow. One thing very, very briefly. We'll do the rest of these tomorrow in class. I am going to push back the 3.2 homework because of the shortened schedule. We did not get nearly as far as we needed to. Plus, that is a very, very long assignment. Guys, saying that I pushed it back, do not wait until the end of the weekend to start on that assignment. You will not get it done in time. Open it up each night. Do a couple of problems each night. There will be a lot of pictures to upload on this assignment. One final thing. Do you guys remember earlier on in the year where I told you there would be a piece of paper going around where you confirmed, yes, I want to take this class for college credit, or no, I don't?
Yeah.
That will be going around at the beginning of class tomorrow. If your name is not on the list, but you do want to take the class for college credit, there's a blank page at the end where you'll fill in your information. Otherwise, I just need your signature under the correct column of, yes, I still want this class for college credit, or no, I've changed my mind.
Would you have